Hi, welcome to this tutorial. Today we're going to talk about FSRs or force sensing resistors. We're going to make one from scratch. We're going to do a homemade one, and then we're going to hook it up to our Arduino and look at the code. Is a FSR, a force sensing resistor? Basically, it is just like the name implies. It's a resistor that changes its resistance as you press on it. So the more force you put into it, the more pressure you put into it, it changes the resistance. So you can get a continuous change sensor out of that, so that you can have a reading that's, say starts at a lower value and then rises as you put more pressure on it, or vice versa, depending on how you map it. Okay, so the materials you'll need for it are some kind of electrode. So I have some copper tape here, and we'll be making a special electrode with it. You'll need this velostat, and it's available. So the copper tape is available from most electronic supply stores, or oddly enough, from your garden supply stores as well. I think they're used to get rid of slugs and snails. This is velostat, which also is available from electronic supply stores, but probably not your garden supply stores. And yes, this is the semiconductor material that changes the conduction with pressure. All right, and as well, we have a little bit of hookup wire. We have a bit of wires to make for our electrodes, and we have a 10K resistor. That's a 10K resistor there, as well, of course, as our Arduino. Okay, so let's get started. First thing first is we are going to assemble our electrodes. Okay, so basically you're making kind of a sandwich. You have your conductive surface on one conductive surface, and we're gonna make a wire that goes to your Arduino. We have the velostat between the two, and then this conductive surface face down on top of that. So then the velostat is between the two conductive surfaces. So you notice the velostat is slightly bigger than the two. We don't want ever the two electrodes touching each other directly, otherwise that'll mess up our FSR. So then as you put pressure on it, the resistance, the velostat is actually your variable resistor. The resistance changes as you put more and more pressure on that. Okay, so since this is adhesive tape, it's sometimes useful to get conductive copper tape with conductive adhesive. That's available as well. It's more expensive, but we're going to make do with this tape that doesn't have conductive adhesive. And so what we're going to do is, so normally if you made an electrode, you might put a blob of solder there, but since they're facing each other, you might get a little bump there. So what I'm going to do is I'm just going to roll the tape over and put the contact side, change the contact side, so that they're all three surfaces are flat when pressing against each other. Okay, so let's go ahead and peel off a little bit of the backing there. See if we can do this. The copper tape is quite thin. It's a little bit tough, a little bit tricky to work with. Okay, and basically just going to fold it in on itself. Bend that back a little bit and fold it. I already got it stuck to itself on the wrong side. Basically fold it in on itself. So I have a little piece on the sticky side with which I can make a contact. Okay, so if now I can solder onto this, and yet it leaves that side, the reverse side, flat. Okay, and I can trim my tape here when I go ahead and do that. Trim the backing, I mean. Okay, so I'll do the same thing with the other one as well. Remove the backing, some of the backing, and so that's the sticky side now, and then fold it back on itself a little bit. Try to get it as straight as possible, I suppose. Okay. Okay. And then trim that backing there. Alright, so now I have my 2 electrodes ready to go. Trim some more of that. And now I just have to add some wire. So take my wire there. I'll strip both ends of him. A good size one on this side to attach to the electrode. Doesn't have to be too big. And then the other side, this will be to go into the breadboard or for my connection. Okay. And I'll twist, really twist both sides, but I'll just twist the one side because the other side I might want to kind of spread out a little bit into the solder. So I'll twist the one side. Okay, and the other side I'll just leave alone. Do the same thing with the second wire. Fairly longly frayed, and then this one I will twist, twist, twist. Okay, so I have those 2 connections. Now I'm going to do a couple things. My third hand here, and I will tin the wires. Going to get that wire prepared there on my third hand. I'll go ahead and clean my solder. It's kind of nice and shiny already, but melt a little solder on there and then scrub it off on my scouring pad here. And then a little dab of solder there, and then approach it from underneath with the actual solder on top, from top, the soldering iron with the dab of solder from the underneath. Get that nice and tinned like that. Okay. And we'll do the other side of the wire. Now this is the side that's going to go into a breadboard, so I'll try to put a fairly thin coating, and we twisted it up. Do a dab. Okay. And then the other wire as well. Go ahead and clean my soldering iron just a little bit. A little dab of solder. And tin the wire. And you notice that my third hand here has the little bit of electrical tape around each of the alligator clips. Yeah, because those tend to be a little bit too sharp, and the electrical tape is also a tad bit sticky, I guess. It kind of grips a little bit, I guess soft, so it grips a little bit. So it's a nice mod. I didn't do the best job. It's kind of everywhere, but it's an easy, cheap thing to do. Okay, so all those things are tinned up. Now let's prepare the electrodes with some soldering pads. And remember, we're going to do now this side of the electrode. In other words, not this side, but the side we folded over. Okay, and we want to stay. We don't want to get on the adhesive part, so it's just the bit I folded over. All right, so I'm going to do that here. I think I've mentioned this before. It's probably better like on some kind of solder mat or something like that, but this is an old table, so then we'll be quick. So a little dab of solder there. Just going to heat up the copper and then melt the solder onto the copper. Okay, and you can tell if you've done it right. It doesn't bead up. It kind of pulls out. Okay, so a little bit of solder onto the iron. Put the solder dipped side down on the thing. Heat it for a little bit. Melt that and then lift up. Let it cool. Okay, and then we'll do the other one as well. Okay. Now, all we need to do is add a little bit of dab of solder onto our thing. Grab one of our tinned wires and grab the side that looks like it's not going to be jabbed into the board. Okay, and we'll just melt the solder and then see the wire sink into it and then lift up really quick. There we go. Okay. That's maybe not the best one, but that's alright. It'll work. Okay, and then we'll do the other one as well. Clean the soldering iron good. And then a little dab of solder on there. And put our wire the way we want it. This one is a bit too long, so I'll just have it overlap a little bit in there. Oops. It's probably better to have this pasted down somehow. Yeah, it probably would have been worth it to tape that down a little bit and then maybe tape the wire down or something like that, because the tape is light and it kept jumping away from the wire. Okay, so great. So I have my two electrodes now. Connected to a longish piece of wire, and that will be ready to go into a thing. So basically what I want to do is I want to sandwich the connective side between the two electrodes, a velo step between the connective side of the two electrodes. So if I take that, I basically put that there, and then put the other one on the bottom. So if I take, maybe the better way to do the sandwich is like that. So the electrodes with the copper side facing up, and put the velostat over it. Okay, and then put the next electrode of the things facing down. So that's basically what you want. Okay. And that'll give you a nice flat FSR. Alright, so what I'm going to do a lid. This is a Chinese takeout container lid. I suppose you can use like the lid from a can of peanuts or any kind of can, or this is kind of big, but a can of tennis balls or something like that. Pringles, yeah. So or anything you want, or it doesn't even have to be on a surface. You can be a flat. You just paste it down to a piece of wood or plexiglass. This gives a little bit of a feel. So we'll make but it's kind of huge. We'll make a thing, and maybe I'll have it so it can kind of be, a foot pedal. So we're doing some things with a foot pedal. So there's a little dimple there in the middle. Maybe I'll just make it kind of down below the middle. Okay, so I'm going to take one of the electrodes. I'm going to peel the rest of the backing tape off. Okay, and I'm going to stick it down onto my lid. Okay, stick it right down onto my lid. All right, and then I'm going to put the velostat. Sorry for the lighting's not the best on this white table. Stick right down onto the lid. A bit of glare, something like that. Get rid of that glare. Okay, and then put the velostat on top of that. And I forgot to mention that it's handy to have maybe some electrical tape or something like that nearby. So I'm going to cut a little piece of that off. Oops. Slightly wider than our FSR. Okay, so I have that. Have this stuck down on top. I'm going to try to place this as much as possible the shiny side, the not adhesive side down, shiny side down, place this as much as possible where the other one was, you know. So, well, there's a lot of room there for error. So we're just going to put it there like that, something like that. Okay, so that's on top of there. Okay, and then we'll just do an initial tape down. Just take that down so it stays put. Okay. And since this is a force sensing resistor, it responds to pressure. You don't have to make contact, so nothing has to be conductive. So I can just cover the whole thing up with tape, and that's what I'm going to do. I'll remove this backing so that the adhesive will help me, and make a couple more pieces of tape here. The end is kind of curled, so I'll do that part first. Yeah. Try to get it as nice and flat as possible. Okay. And then I'll continue that process there. A couple pieces of tape. To cover up that sticky side of that backing. Trying to keep everything nice and flat. Okay. So I have the dimples there, but I can use this as the sensing part, and then I'll just one final piece of tape there to just do a little cable security there. So if I give a yank on the cables, it doesn't pull my sensor out. Okay. And then the natural sort of flex of the gives a little bit of tactile feedback. The flex of the lid gives a little bit of tactile feedback. Okay, so there you go. You have your FSR, your force sensing resistor right there. So I'm excited to see if it works. Okay, so let's make the circuit now. Let's grab my Arduino, and I'll zoom in just a little bit. We'll make the circuit now. So one end of either end of the force sensing resistor goes right into the power, 5-volt power. You can put it in a 3-volt, you'll just get less headroom, you'll get less resolution. And so I'm going to put in this Arduino, I have a Arduino here, and I'm going to stick it into the VCC port, which is the 5-volt. Okay, so that's one end just directly into 5-volt. Okay, now the other end we're going to create a voltage divider. We're going to divide between ground and one of the analog ports, and it's going to read. So I'm going to pick a rail here. How about rail 22? Okay, and then I'm going to take, and that's the other end of my FSR, and I'm going to take from that same rail, I'm going to go through a resistor. I'm going to go through this 10K resistor. I'm going to go from just the same rail, the next connection. Okay, that same rail there, and I'm going to go to analog 0. It's a bit hard to see on this board. I have some shadow problems, but that row 10 there you see is analog 0. So I'm going to try to get that in there. Oh no, I'm sorry. Okay, this goes to ground actually. Okay, so it goes from there to ground. it's not touching anything here. Anything else? Okay. So that's going to, oops, do I have it on the wrong one? Yeah, I have everything over wrong because hard to see. So that's going to ground, and this is going to VCC. Okay. Row 13 there is ground, and then row 12 VCC from one end of the electrode or one end of the FSR, and then the other end goes to a rail that first to ground through the resistor. And then after, so that's the same rail though. First connection goes from the rail to ground, and then the next connection we're going to take some hookup wire, and we're going to go just same rail after the ground though, after the resistor, and we're going to go into analog 0, which is rail 10 there. Okay, analog 0. Okay, so real simple circuit again. One end of our FSR into the 5 volt, the VCC there. The other end into a rail, and the first connection after on the same rail after the FSR connection goes through a 10K resistor to ground, and then after that on the same rail goes from the rail to analog 0. Okay, so we're using our analog ports for the FSR. Okay, so we should be good to go. Now let's have a look at the software. And it's just a very simple analog read. So the code is quite basic. It's your standard analog read code. We'll create a couple variables for INT-FSR for the pin that it's connected to. So equal pin 0. It's connected to analog 0. And then we'll create a value variable, FSRV. All right, and then we'll do a setup. And we'll start the serial monitor there. And 9600 baud. And then we'll create our loop. And then we'll grab the analog read and assign that to the FSRV, the value. So FSRV equals analog read, and then read that pin, FSR pin, the analog 0 pin. And then we'll print. And add a delay. We can just make it 15. It'll be a lot. Okay, so really it's very straightforward code there. Let's upload that to our Arduino, and then look at our serial monitor. Oops, and have a look and see what that looks like. Right, so it's reading at about 100 at rest, and then as I push it slightly, goes up 2, 3, 4, 5, 6, 7, 8, 9. Push it really hard, I can almost get it to 1,000. Not quite. So there you go. So you have, it's not quite as discrete as a potentiometer, a pot, but you get a nice sort of, a nice gradual reading up as you push on it. And it kind of helps to have this tactile little lid device. I'm sure those amongst you can come up with a much better sort of tactile function than this, but it's cheap and easy to do. So there we go. We have our FSR. Okay, so we can stop there, and that'd be fine. But I also just want to include, and I know I've included this in other videos, but I just will be reiterate and redundant. You can make these a switch if you want. Well, you can do loads of different things with FSRs, but one thing we'll cover just now is a switch. You can also use them to be velocity sensitive, but maybe we'll do that at a different tutorial. So, like I've done with other things, the buttons or the capacitive sensors, etc. We will create a gate. Okay, and we'll make that true. And then we'll just have if FSRG, if it's true, then print that. Right, and then here is we'll have some kind of threshold. So you know, you can set it for whatever you want. You can say if FSRV is greater than, say, we're going, say, like 500. We'll make it about halfway. Okay. Then, so and then we'll make it true. So we'll make it false. FSRG equals false. So if it's true, it is default, it comes through. Once it's greater than 500, it'll close that gate and it'll print one value. Okay, and then else, well, we'll just do if FSRG is not true, is false, and if FSRV is less than, we can make the threshold. So he's going down to about, so maybe make this a bit bigger, say 600. Maybe make this, it was hovering around 150 or something at rest, so maybe like 300 just to be extra certain. And then we'll say FSRG equals true. And let's just have some kind of, I mean, I guess if you wanted to make it switch, you would make it a 1 or 0. But let's have the value, let's print the value, and let's print some, well, we can put in all our headers. And we'll make this FSR1. And then something like that. FSR1. Well, we'll just put on FSR1 on, something like that. And then this will be, I'll just copy these here. Off. Okay, so there you go. So it's a code I've done in previous videos. Basically, it just allows you to have a gate so that it becomes a switch instead of a continuous reading. FSR is a lot more useful as a continuous readout. It can be, you know, kind of like a potentiometer, maybe not quite as smooth. But here we can use them as switches as well. Okay, so I will save this as actually FSR switch. Okay, and then we'll upload that code. Oops, I didn't put a semicolon there, nor did I put one there. Tisk. Okay. All right. So basically, if it's on, off, on, off, on, off, on, off. Oops. So you see if I'm pushing kind of lightly, it's not going to go, so I have to actually hit it pretty solidly. Okay, well there you go, FSR tutorial. These are really useful, easy to make, and quite inexpensive as well. So hopefully that is useful for you, and good luck with it.